Good morning, everyone. We are Group 8. This is our hands-free inventory tool. My name is Merlin Loetzner.
My name is Kelly Castanon.
My name is Wisam Aboona.
So before I go into the video demo, I'll tell you what you're going to see. You're going to see me run a program, and you'll see a title screen, and then I'll click past it. And then you're just going to see my webcam feed. And then I'm going to hold up a handful of objects that we have coded in, and then the video feed is going to detect what those objects are, and it's going to open up a hyperlink for that object. So our concept is kind of like the next generation of barcode and trying to just have a more intuitive inventory tool rather than a barcode scanner. So let me play the video. So there's my camera feed. So I hold up this record right here in front of the camera, and once it detects it, it'll show you that the image was found, and then it'll open up the appropriate page for that. So you can see that's the same album cover there. So the important thing that I had in mind was that not every object has text or identifying barcodes or anything on it. So if you're able to detect it with this, it makes it easier for people to find objects. And it also does a wide range of objects. And here with this example, you'll be able to see it does a different orientations as well. So that was upside down, kind of crooked. I'll do it again completely sideways, and then it'll find that page as well. And here you can imagine too, this being part of like a bookstore or something, that you can immediately buy it if you want to. And then finally, to prove that how versatile this is, I'll show you it works with not rectangular objects as well. And here's an example of a misdetection too, which happens with different lighting conditions here. But if I hold up this guitar to the webcam once it detects it, sometimes you have to play with it a little bit, and then I'll open it up and there's the product page for it. So then I'll start the live demo, and we'll show you how it works. So here's that title page that you saw, and there's just a taskbar right now to open it up. And then, oh, I gotta disconnect my webcam, hold on. Stop video, there we go. We learned that lesson from the first presentation day. There we go. So I'm gonna hold up that same record here, and here you'll see there's a plastic cover on it, so there's some glare and it does affect it, but it's still able to find it. If I press Q, it'll keep going on the camera feed, and I'll do it again without the sleeve, and it'll go a little bit quicker normally. There you go. So we'll run through some of the other objects I've trained. So the thing with this is there's lighting conditions affected a lot. So you can see the glare on it is because the lamp I have is directly next to my computer, and that does have a lot of glare, and sometimes it does affect the matching a lot. Hopefully we can get this to go. We'll try a different object. So you can see here, there's an example of a misdetection. And again, that's a lighting condition thing. And I found with these two books, they really liked to mix up the matches with them for some reason. And that was sometimes frustrating while I was trying to calibrate the system, but all right. It's fighting me a lot today. Try again with this. There you go. So there you can see an actual correct match. I was holding it up sideways and it worked. And then we'll try again with the last object here with the guitar. See if we can get it to detect. There again, it still thinks it's this one book. All right, I'll just move on. It seems that the way that the light is happening this morning is really affecting it, but we'll move on to the live presentation, or the presentation rather. All right. I'll pass it off to Kelly.
Good morning. So as Merlin said, our design is for the next generation of retail scanners. This device is capable of detecting whatever product you hold in front of the camera. It won't require you to manually enter in the product's name in a search bar or have prior knowledge of the product, and it won't require the product to have a lot of written information on it, as Merlin said. It's a user-friendly interface and will be perfect for all retail environments as it only really requires a camera. So to create the device, we use key point matching. For those who are unfamiliar with this, key point matching uses distinctive invariant features and images to match items. So it uses unique points to match two images. We use this method because OpenCV natively has the tools required to accomplish this, and it allows for real-time matching. And it was also manageable for the time frame that we were given. The image below shows a visual example of key point matching actually occurring. And as you can see, all the points match for the albums. So upon opening the device, the title screen shows up as shown below in this slide. Due to the time constraint, we ended up using a track bar to simplify moving forward to the next screen. In future versions of this product, we plan on creating buttons so the user can choose between being linked to opening Spotify, Amazon, or Google, depending on if they want to listen to the product, purchase the product, or learn more information about the product. I say buttons because OpenCV doesn't really natively have buttons, so I thought we could make an event occur based on RGB values of a button. However, we ran into a few complications, so you can look out for it in version 2. Next, Merlin will be talking about matching and detection.
Thank you. So like Ellie said, we used key point matching, and that is approach we learned in earlier in the semester, and it lets us do live camera feed detection using stored product images, and these key points are compared in real time. So, and these matches are decided on a calibrated matched key point quantity. So I'll talk about that here. So when the program first runs, it calculates a handful, or it calculates the key points for the stored images, and you can set the maximum amount, and we used 1,000. And here you could see for these 3 images, it found 1,000 for each of them, but not all the images we had stored had them. So here's the other 2 objects we had coded in. And again, like the first one there, you can see is 322, and the second one is 775. And it's just because there's less information on these images. So the one on the left, I didn't show that in the demo because that one was really hard to detect, and I think it's because of the low amount of key points. And there's not a lot of colors, not a lot of information other than the text on there. And on the right, it's kind of a blurry picture, and beyond the text, there's not a lot of information there. So, and so we needed to calculate detection thresholds. So the every frame there's matches being detected, and we decided to find detections by the amount of matches found compared to the maximum. And so this was calibrated in a trial and error process. So we wanted to, and part of this was balancing quick detections with misdetections. So you would want the product to be found pretty easily by holding it up to the camera. But if you do that, it's easier to have a misdetection, either an idle or just holding up the wrong object. So you have to balance those 2. And then I noticed there's some sort of pattern with this threshold I'll show in the next slide, that this could probably be an automated process because it would not be reasonable to have a manual calibration for like a database of Amazon's products and stuff like that. So here you can see the thresholds I decided I calibrated for these objects. And I also, below that is a proportion from the threshold over the maximum key points. And you can see that they are about I would say about 0.25 to 0.35. So I think there is some sort of pattern there. So this could be automated for version 2.0 for a bigger database that already exists. And then, like you saw, once it detects the objects, it opens that product page in Google Chrome at the moment. So you can look at the product page and then you can press Q and keep the camera feed going, and then it'll keep detecting objects after that. I'll pass it off to Wisam.
Thank you, Merlin. Image text confirmation using image show and put text. The display with the image on it will pop up to confirm to the user that the object was found correctly. The text will pop up to tell the user that it was found correctly on the user screen with an image of search on the side to assure the user that the search was done correctly. Next challenges. Some challenges are misdetection and the wrong object coming up. If the camera was just running in the background with nothing to be searched, something might come up because the camera may be running in the background, which first into the misdetection. Wrong object is an issue because the camera might get different views on different things because of lighting. For example, misdetection. As you can see, the first one with the misdetection. Yes, as we can see, first one with the misdetection, and the bottom one is the ideal situation. The bottom situation increase lighting the surrounding, for example, to see how that would reflect the search. You can see on the right how the search went. Now application, next model, please. Application, the camera would be most useful in a retail environment. It lets you scan object without a barcode. Places like clothes shop, food shop would be most useful with this, but it can be used in many different ways. This would be most useful with app that have existing database. Then and run would be used for a way to find product online or in real life, because most smartphone, if not all of them, have cameras, so that makes finding product easier for the consumer with needing a barcode, for example, because most of the smartphone have a camera. Next model. Continuation. So continuation connected that this database of object, automating the threshold calculation, implementing it into an app, PC app, a phone app. For example, this is useful database for app like Amazon or any other digital service will be most useful. I will pass it back to Marlon.
So the overall summary, as you saw in the demo, sometimes it worked really well, and as you saw in the live demo, sometimes the lighting conditions were off and it doesn't work so well. So I think the proof of concept worked really well, and I'm pretty proud of how it works. It's really versatile, as you could saw. It was even able to detect something as weirdly shaped as a guitar, not just square objects with text written on them. The interface is really simple just because it's a live camera feed, and then once it detects it, it opens up the link. And then I think it shows that the functionality can be expanded to be a really useful thing and have different specifications depending on whichever customer it gets implemented for. Thank you. Is there any questions about our project?
Thank you, Merlin. Good job, guys.
I think there was one question in the chat. Sorry to interrupt you. My bad.
I have a question.
Yeah.
Yes, go ahead, Sam.
Could you clarify, is the camera a unique camera, or is it a camera that is either on your on a smartphone or on your computer?
It's a generic camera, so I just was using my webcam either on my laptop or a USB one, so it could be any camera.
Okay, so so you can't just use your phone to to identify an object. No.
Absolutely, yeah.
All right.
Right. So these are vision-based application, meaning as long as you have an image coming from a photograph, from a video, from anything, as long as it has sufficient resolution. So most smartphone cameras, webcam are good enough for this kind of detection, the key point detection.
That's great.
Yeah, Dave, you had a question about lighting, and I know this is a very important issue also. You want to ask the group?
I'm sorry, I had to step away for just a moment there. I missed your question. I'm sorry.
No, I said you wanted to tell the group about how lighting affects these kind of detections and any application.
Yeah. Well, I just, I noticed in that application that the glare was something that was a problem with the one book. And that's why there's so many different types of lighting. If you go to our website, you'll see there's lighting to take away glare. There's dark field, there's bright field, there's bar lights, there's ring lights, there's dome lights. All those different kinds of lights take glare away or add lights in certain components of a product. Something that's very bright has a code stamped into it or something like that. Needs to bring that code out away from it. Color, white lettering stamped on a white product. Sometimes you need computational imaging or something like that to make that stand out. So there's just, they say lighting is the black magic of making a machine vision application work. So it's just super important that you try different types of lights at your disposal and find the right one for the best application to make it work.
Thank you, Dave. So I have to add that as much as we want our applications to work in any condition, any lighting, we're not there yet. There is still so much to do before we can reach that point. So before we reach that state that your algorithms are robust enough to work in any condition, lighting is one very important thing we need to control, that as much as we can. If you can do that, you're going to get very good results for your application.
Yeah, we find quite often in applications, for instance, in a factory, that it might work, the application might work well in the morning, but as the sun actually goes higher in the sky, if there's a window in the facility, that light comes down into the building and just wreaks havoc on the application. We'll get a bunch of rejects all of a sudden, and people wonder why. It can be something that small.
Yeah, I noticed that when I was calibrating those thresholds, was that if I was doing it in the morning with light coming through my window versus now at 5 p.m. when the sun goes down,
Yep.
It's a very different thing. And the
Absolutely.
performance changed every minute.
Absolutely. It can be a little bit. Yep.
Right.
Any other questions?
I have a quick question. This is Denise from GVSC. Did you do any work to understand how the background plays a role? I was wondering, you may have mentioned this, but I wasn't sure, especially when you were doing your demo, when you were holding the books, you were kind of holding it away and out, but when you held your guitar, you had it really close to your body. And I'm just wondering what kind of role that plays, if you guys had a chance to look into that at all.
Right, so I noticed that with different objects, certain areas of the objects the program liked more. So like when I was holding up the guitar, it really liked this area down here just because I think there's a lot of information going on here.
Yeah.
And there's a lot of differences in edges.
Mm-hmm.
And then with objects like, I don't know, with this one, I found it better when you could see the whole thing and it was farther away and you could have it as sharp as possible. So
Okay.
it was just from playing with it, things changed. And like this one as well, there's a lot of colors and information here. So it's better to show this side than up here. So
Yeah, I think you picked that album to try to get old people like me excited. I wrote the chat, and when I saw that, that was really good. I mean, the reason why I'm asking is we have problems. We have lots of users. Whenever we come up with any sort of technology, we have a lot of users, and we're always trying to standardize methods to take basically the user out of it. So I was just curious how much the person holding it and how they're doing it played a role. So thank you. Great
Yeah,
work.
for sure. So it would have been interesting if I grabbed my roommates or something who have no idea what I'm doing in here to have them try to do it. It would be interesting to see how the performance changed there as well.
Exactly.
So yeah.
Thank you.
That was an excellent question, Denise. I was going to ask about the background, but I have to say your taste in music and books is good.
Thank you.
The background, see the algorithms you're using, the key point, it's looking at the entire image to detect key points, and the background matters. So maybe in the next 2.0 version, if you touch an object on a screen, it will try to isolate that object first and put an region of interest on it, do a boundary detection, and then recognize key points in that area. That will result, more robust matching, because right now it's doing in the entire image, all the key points in the image, and trying to match it with your database. So, but for 2 weeks time, that's an excellent result, to get to this point and make it work. I think you guys learned a whole lot, valuable lessons doing it. Excellent job. Any last questions for the group before we move on?
This presentation reminded me, it took me back 20 years or so. We were studying for image processing, and we used to say, when we prepared for the exam, when in doubt, convolute it out. That was our, just do a convolution. Probably on the test, they're just gonna be asking what's convolution. Now, I would like to learn more a little bit about the algorithm you're using, because you say there's no prior knowledge, but then you are matching a webcam image. You are matching a webcam image with the, with key features with an existing image in some kind of a database that you train. So there is pre-knowledge. Can you just tell me a little bit, are you doing some kind of convolution like we used to do? Or what's the basis of algorithm when you talk about keywords or key points?
So this was, this was based heavily on a homework assignment we had earlier in the semester. So you could see basically all the images that I had in there were just basically stored within the program itself. And the key point matching programming inside OpenCV is so robust that it does a lot of this detection and computation just in a single line of code. So I don't really know what's going on with those things. I can take a guess, but beyond like the actual like algorithms it's using and like calculating and storing those key points, that's not, I didn't dive that deep, unfortunately. Yeah.
Well, back in the day, we didn't have these tools, so we had to do this. But we didn't get this far either in 2 weeks, so it's pretty impressive. All right, thank you so much.
So, Osama, that was a great question. So this is why I did teach them about convolution, because it's based on convolution. The location of key points is detection of areas in image which are unique from gradient point of view. So it can be identified scale invariant, rotation invariant detection. And as Merlin mentioned, that these newer tools we have, OpenCV tools and even MATLAB, have built-in functions which are based on convolution. So if we had implemented convolution and for matching, it would have taken way more than 2 weeks for them to do. So they
for sure, I know. Yeah, I'm just curious. Yeah. That's amazing what the tools can do today, yeah.
Absolutely. The entire machine vision is based on convolution. That's what makes it work. Every algorithm in it.
So when in doubt, convolute it out is a good motto to go into an exam, right?
Yes, absolutely. Absolutely.
Thank you.
Excellent. Any other last questions? All right, great job, Group 8.
Thank you.